In this video, we are going to discuss a question which has appeared in KVPY 2021 in SX stream. So question is from Projectile Motion. Let us read the question and see how do we proceed. So question is that there's a projectile that is launched from the origin in XY plane. X is horizontal, Y is vertically up direction, and the launch angle is alpha from the x-axis. And R, the distance, is root over x square plus y square. So R is this. You can see in this graph. Suppose the projectile is here, then its distance from the origin is r. This is plotted against x. This diagram was also given in the question. The resulting curve shows different behaviors for two launch angles alpha 1 and alpha 2. So there are two launch angles alpha 1 and alpha 2. Actually, these angles are not alpha 1 and alpha 2, but they have marked it that way. Alpha 1 and alpha 2 are the angles, launch angles, right? So R1x, now the important information here is for alpha 1, Rx keeps increasing, this black graph. For alpha 2, Rx increases, you can see here, reaches a maximum, this point, and then decreases, goes through a minimum, decreases, goes through a minimum again. And the switch between black and blue graph happens for an angle alpha c, which lies between alpha 1 and alpha 2. This is given. So we have to find out the value of alpha c. So just one point here, the distance is root over x square plus y square. So r square is x square plus y square. Now for this graph to exist, these 2 points, rather these 2 points to exist, then at this point and this point, at both points, dr by dx would be equal to 0, right? Slope is 0. So that is what I've written, that dr by dx would have two real roots. So that is what now I'm going to do. Apply this condition and find the answer. Simple. Equation of trajectory was given to you, at least even if it is not given, you should remember the equation of trajectory. So r square is equal to x square is as it is, and y square. So this I have squared here. So when you square this, it becomes like this. X square tan square alpha, and the square of this term, you can verify, and then minus 2, this term. So that is how you get one x cube term, x4 term, x square term, right? 1 plus tan square alpha is secant square alpha. Now after that, I have differentiated this. Because dr by dx equal to 0, so I have two real roots. So if I differentiate, it becomes 2r dr by dx. Since r is not 0, only at origin it is 0. So 2r dr by dx is equal to this. Now 1 plus tan square alpha, I've written secant square alpha. X square is 2x. This becomes this x, everything else is constant, right? We are doing this for a particular alpha. And x power 4 becomes 4x cube, 4 cancels, this is cube, and here you get square. So this is a cubic equation, but if you take x secant square alpha outside, other than origin, x is not 0, right? We are actually looking for points where x is not 0. So if I take x secant square alpha common, then it becomes a quadratic equation. And dr by dx is equal to 0. So for now, again, the same thing. For these 2 points to exist, this quadratic should have two real roots. You know the condition. What's the condition? A determinant should be greater than or equal to 0. So this is ax square plus bx plus c. So determinant v square is greater than 4ac. You will see that g square and v power 4 cancels, and you get sine square alpha greater than or equal to 8 by 9. Sine alpha becomes 2 root 2 by 3. So that gives you cos alpha equal to 1 by 3. This was the answer given, right? So it's a very good question. Now, if you actually condition the exam environment, if you think solving this in exam environment, then definitely it is a difficult question. But if you have done this patiently, found this x square plus y square, and applied the condition, whatever is given in the question, then those students would have got the answer. Fine. So that's it. That was my analysis. If you like the analysis, please like this video and please subscribe to this channel also. Thank you very much.